Okay, so here's question number 5 on the 2008 practice exam. I'll focus on A first here. So some of you have already done this, so let's just check the slope fields here. So again, you plug in each point. If you did a 0, 0, okay, you're going to get divided by 0. So whenever x is 0, we have a vertical line. So we're going to put vertical lines there wherever x is 0. Wherever y is 1, we're going to put a horizontal line because that makes this slope 0. So y is 1. Going to be zeros. So 1, 0, 1, 0, that's going to be negative 1 over 1. So it's going to be a negative 1 slope. And then the 2, 0 is going to be negative 1 over 4. So it's going to be a quarter slope and so on. So I'll just kind of fill some of these in. Looks like that and like that. Okay, so kind of looks like that, which is arguably pretty tough to figure out what's going on there, right? As far as the slopes go, could be something pretty crazy. So B, let's focus on B. Find the particular solution. So here's our initial condition, so we can find what C is when we do our differentiation. So this is a separable differential equation question. And so I'm going to take this and I'm going to separate my variables. So that means I'm going to get, now you got to be careful with this because you can't get the x squared up there like we normally do, because look at, that's where the dy is. So you can't do that. Instead, you're going to have to divide the y minus 1 off and bring it down here, and the dx has to come up here. So we're going to end up with this one right here. It's going to be 1 over y minus 1 dy equals 1 over x squared dx. Now this 1 over x squared, this does have a it does have an exponent that's not 1. So you have to be careful. This is not a ln. This is not natural logarithm. This actually might be easiest to show it like this, right? X to the negative 2. You do your power kind of rule there for integration. So we'll integrate both sides now. Now that we have the y and the x separated, and on the same side is their dy in respect of dx there. So we take the integral. Now this is just to the power of 1. Okay, this is just a quantity under here. So that is going to be a ln. So it's going to be natural logarithm of absolute value of y minus 1. And there's no number in front of y, so we don't have to divide it off. We don't have to undo the chain rule by dividing off by the coefficient. You don't have to do that. So this is good. And then now I'm going to add 1 to the exponent here and use kind of the power rule there. So that's going to be x to the negative 1, and then I'm going to divide that by negative 1. So it's going to be negative x to the negative 1. Okay, you good with that?
Yeah.
Plus c. All right. Any questions about that or any struggles with that so far? Okay, so separating those variables, a little bit odd. We have denominators on both sides. Okay, so now let's put in our, 2, 0. So x is 2 and y is 0. So let's do that. So we have ln of, now this is, remember, this is absolute value. So this is 0 minus 1. And this is negative 2 to the negative 1. And that negative is outside the brackets and everything. So ln of absolute value of negative 1. This is negative 1/2, because this is 1 over 2, and this times negative. Now this ln to the negative 1, okay, that's the absolute value, so that's going to be ln of 1. So e to the power of what gives us 1?
0.
So what is this? The value of this is 0. Yeah. So 0, and then plus 1/2 equals c. So c is 1/2. Good with that? So now that we've got our c value, that's awesome. I'm going to go back up here to this stage right here, and I have to plug in my c value now, and I'm going to solve for y. So I'll do that in blue over here. So ln of absolute value of y minus 1 is, now I could put negative 1 over x here, I guess, if you want. That's the same thing. Plus 1/2. And of course, to liberate y from the natural logarithm, I have to understand this is base e, so we're going to do e to the power of this whole side, right? Equals absolute value of y minus 1. So y minus 1 absolute value equals e to the power of negative 1 over x plus 1/2. All right, so y minus 1, if I eliminate those absolute value signs, I have to make a choice here whether this is going to be plus or minus. So I'll just take this one step at a time. And then I can add the 1 here as well to the other side. So now y equals this, but I have to figure out if this is going to be a plus or a minus here. So I have to, I guess, take a look at my initial conditions, which is 2, 0. So here's the point. Okay. So if I plug in 2 in for x and 0 in for y, let's just see. So 2, so that's negative 1/2 plus 1/2. Okay. Plus 1 on the outside. So this is going to be e to the 0. What's that going to be? That's going to be 1. So 0, I have 1 plus 1, and I have to decide what sign this is going to be. So what's that going to be? That has to be a negative to make that true. So that's how I choose the negative portion. Okay. So from here, I'm going to write this now in red. So it's going to be y equals negative e to the negative 1 over x plus 1/2 plus 1. I'm satisfied with that. In the past, we've simplified this a bit. So this technically is okay, but if you remember that, I guess this is the tricky part because of the negative. So if that's a negative there, you could see this as what, e to the negative 1 over x times e to the 1/2 plus 1. Is that gonna help? That's not gonna help to simplify, really, is it? Because this e to the 1/2 doesn't really simplify. It's a root e. So it's not going to simplify. If this was a ln something in here, then e to the ln, you'd want to simplify that. But this is not necessary, I guess. So here you go. This is good. Yeah. Okay. And then, so is that good for B? Does that help for B there? Yeah? Okay. Now let's look at C. What is C? It's a bit of a different type of question. For the particular solution y equals f of x described in part B, find the limit of f of x as x approaches infinity. Okay. So as x approaches infinity, what's going to happen there? So let's do some blue. So C, we're looking for the limit of, this is like the negative e to the 1 over x plus 1/2 plus 1. So as x approaches infinity, I guess the only place where I see x is here, and it's a 1 over x, so that's kind of nice. As x approaches infinity, this does come to a certain value, doesn't it? What does this come to? 0. So that's going to equal negative e to the 0 plus 1/2 plus 1. Or the limit equals negative e to the 1/2 plus 1. No fancy footwork in evaluating this limit at all, just pretty straightforward. Okay? All right, let me know if you have any problems with this question as a whole here. So that's the whole thing on the screen there. You have any questions? Okay. You guys are good, or yeah, you just.
Yeah.
That was easy.